Assalamu alaikum students. In today's lecture, we are going to discuss an improper fraction. In the last lecture, we did questions related to proper fraction. So today we will do 3 questions which are in exercise 5.1 about an improper fraction. Yes, girls. For an improper fraction, it can be reduced by division to a mixed form consisting of the sum of a polynomial and a proper rational fraction. Here I will explain with the help of an example. 3x square plus 1 divided by x minus 2. Yes, students, look at the power of x in the numerator. It is 2, whereas power of x in denominator is 1, as the degree of numerator is greater than degree of q of x, that is denominator. So what will we do? We need to convert given question into compound fraction. We will use method of division. With the simple method of division, which you have already done, now divide. Here come 3x, so it becomes 3x square. When you multiply it with 2, it becomes minus 6x. By the rule of division, signs will be changed, so the next term is 6x plus 1. Again, for the second time, when we divide, it becomes plus 6. So it is 6x minus 12. Again, change their signs. So here we have 13. So the compound fraction becomes this 3x square plus 1 divided by x minus 2 is equal to this. Using remainder theorem, here quotient is 3x plus 6 and divisor and the remainder is 13 divided by x minus 2, which can be written as 3x plus 6 plus 13 divided by x minus 2. Now look at this second term. This value is a proper fraction. So now we will apply the method which we have already done in remaining questions. In other questions of exercise 5.1, we will follow that method and simplify 13 divided by x minus 2 and with the help of partial fraction, and we will get result. This one is the method to convert any question, an improper fraction, into compound fraction. Yes, girls. Here in exercise 5.1, look at question number 6. In question number 7, 8 and 9, These are questions of improper fractions. So what will we do? We will follow this example and simplify these questions first by converting into compound form. Then we will apply partial fraction method. Yes, girls. Today we will start with case 2. In case 1, it was when we have only non-repeated linear factors in the denominator. Here in case 2, we will solve our questions when we have repeated linear factors. Okay. With the help of this example, I will explain you how to resolve this question. Let we have an example 1 over x plus 1 whole square, x square minus 1. Look at the bracket. There is square on the bracket. So it shows that this factor, this linear factor, is repeating twice. Now, first of all, we will solve this second degree factor. Factorize this second one. It becomes x plus 1, x minus 1, because we know that third formula 1 over because a square minus b square is equal to a plus b and a minus b. We will use this formula in solving second factor. Here we have x square minus 1. So when we solve this, it becomes x plus 1, x minus 1. Now look, students, that here x plus 1, we have one more factor, x plus 1. So it becomes x plus 1 raised to the power 3 and x minus 1. Now apply method of partial fractions. We can interchange these two values. Write this factor with power 1 at first place and this second one at second place with the power 3. Let's start. For first factor, a divided by x minus 1. Now come over second factor. For second factor, put plus. As we have 3, power 3, begin with b, x plus 1 with power 1 on bracket. Then c divided by, again, same linear one. Now there will be written 2, and for the third one, d divided by x plus 1 raised to the power 3. This one is the method. Remaining procedure is same. Multiply both sides with this denominator, x minus 1 and x plus 1 whole cube. When we multiply both sides from left side, these two factors will be cancelled and we will left with 1 is equal to a. It will be x plus 1 cube plus b, 1 x minus 1, one of the factor will be cancelled and it becomes x plus 1 raised to the power 2 plus c, x plus 1 square will be cancelled. So we will left with x minus 1, x plus 1, and for the d, x minus 1. First of all, we need to open these values. We will apply formula of cube. Plus b, first one. In the second, we will apply formula of square plus c x square minus 1 using this formula, above formula, plus d of x minus 1. X cube plus 3x square plus 3x plus 1 plus b x cube plus 2x square plus so after simplification and by opening these brackets, so girls, follow this example and solve exercise 5.2. Here in first question, in denominator we have x minus 1 raised to the power 3. Again, you will use repeated linear factors. In second part, in third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. There are 12 questions, and in all these questions, we will apply method of repeated linear factors. Case 2. I hope you understand and you will successfully solve this exercise. Thank you so much, students. So girls, follow this example and solve exercise 5.2. Here in first question, in denominator we have x minus 1 raised to the power 3. Again, you will use repeated linear factors. In second part, in third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12. There are 12 questions, and in all these questions, we will apply method of repeated linear factors. Case 2. I hope you understand and you will successfully solve this exercise. Thank you so much, students.